So let's take a look at two problems in section 3.8. In fact, the first two ones from Achieve, number one, and then we'll look at number two. So number one wants you to differentiate an expression with respect to t. T is the independent variable in this case, and x is actually the dependent variable. X is a function of t. I know we're used to having x as our independent variable, but in this case, x is a function of t. In other words, it's dependent upon the value of t. Now we're going to be finding, therefore, a derivative, and involved in that will be, no doubt, the derivative of x with respect to t, dx dt, which we're going to use x prime to represent that in the actual problem. Here's the expression that we're taking the derivative with respect to t. Notice that it is t to the 6th times x to the 5th. If you have a product of two functions of t, which we do, you have to use what? The product rule, right? This is the product rule of finding the derivative. So I take the derivative of the first function, t to the 6th. Notice the notation here. This is d over dt. This is, and when you're taking the derivative of something, the d over dt indicates, take the derivative with respect to t, and then in parentheses or afterwards, you should have the function you're differentiating. Okay, having that by itself is nonsense. You can't have this operator by itself. This has to operate on something. It's the derivative with respect to t of this expression. Notice that's different than dx dt. What exactly is dx dt, by the way? Dx dt is the derivative with respect to t of x. Right? This is the dx dt notation. We're finding the derivative with respect to t of x. So be real careful about notation. Some of you are a little lazy and sloppy when it comes to using the correct derivative notation, this Leibniz notation. So really practice and get used to that. It's important. In later courses, you'll need to be familiar with this notation. Okay, back to the problem, taking the derivative with respect to t of the first function times the second plus what? The first function times the derivative with respect to t of the second function. Now the first derivative here on this side, right, since we're taking the derivative with respect to t and it's t to the 6th, that's just straight up, right? Derivative of t to the 6th by the power rule is 6t to the 5th. That's easy. But here's the derivative with respect to t of a function, right? X, right? Remember, x is a function of t. Well, what function of t? We don't know. Okay, but we don't need to know because I have an inner function of x, an outer function of x to the 5th. This is going to be a chain rule, right? Or generalized power rule. Take the derivative of the outer function, that's bring the 5 down, x to the 4th, right? That's the power rule, times what? The derivative of the inner function, the derivative with respect to t of that inner function. What's the derivative with respect to t of x, right? Derivative with respect to t of x is dx dt, right? Which is x prime, which is the notation we're going to use. They're all the same thing. So it's the derivative of that inner function. So I get 6t to the 5th times x to the 5th plus this 5 I'll bring to the front, t to the 6th, x to the 4th times this stuff, which again is x prime or dx dt. This is what they want you to enter into Achieve. Okay. 3.8, number 2, very similar to this one. We're finding the derivative with respect to x of the function y divided by y plus 15. So notice it's with respect to x, and we have y. So y is a function of x here. Y, we don't know exactly what function, but it's a function of x, and therefore we're going to be looking at dy dx, which again, keep in mind what this means. This is the derivative with respect to x of y. All right, that's what we mean by that, which we're going to use y prime for that notation. Okay, what do we have here? I'm taking the derivative with respect to x of one function of x divided by some other function of x. I'm going to use the quotient rule, right? Quotient rule. You take the derivative with respect to x of the top function times the bottom minus the top function y times the derivative with respect to x of the bottom function, all over the bottom function squared. What's the derivative with respect to x of y, right? That's dy dx, or what we're going to write y prime. What's the derivative with respect to x of y plus 15? Well, the derivative with respect to x of y is, again, dy dx, or y prime. The derivative with respect to x of 15, 15 is a constant now, it is going to be 0. So again, we can't assume y is a constant function. So that's why we need to use this notation. So if I clean this up, I've got y prime times the quantity y plus 15 minus y times y prime. Simplify, distribute the y prime across the top here, y prime times y plus 15y prime. Note that y prime y is the same as y prime. So these two, this minus that is 0. I'm left with 15y prime over, notice the denominator never changed the whole time. No need to expand the denominator, by the way, keep it factored. There's our final result. Okay, so that's and these are important skills when you're doing implicit differentiation, and they'll be important skills when we do related rates problems. Okay, hope this is helpful for you on these problems.